Most substances exhibit what is known as electrical resistance. Resistors are elements within a circuit that take advantage of the characteristics of electrical resistance. Resistors are used to control electric current and to convert current signals to voltage signals. Resistors come in various shapes, sizes, and materials, depending on their use. Furthermore, some are fixed resistors with a fixed value of resistance, while others are variable resistors whose resistance value can be altered. Fixed resistors are denoted on the electrical circuit like this, and variable resistors are expressed like this. Some resistors are color-coded to indicate their resistance value. Color codes can be used to calculate resistance value. Now let us explain how to read color codes. A numerical value is assigned beforehand to each color. Color codes can be printed for any terminal. The fourth color band indicates resistance error. The value of resistance can be determined by applying color code values to a prescribed formula. This carbon film resistor, for example, has yellow, purple, red, and gold color bands, arranged in order from left to right. Their corresponding values are 4, 7, 2, and 5. From these numbers, we can determine that the resistance value is 4.7 kiloohms and the error is plus or minus 5%. The illustration here is an electrical circuit comprising a battery, switch, and resistor. This circuit can be shown with a circuit diagram like this. When the switch is turned on, voltage E is applied to resistor R and current I flows. This relationship is known as Ohm's law. For example, if voltage E is 100 volts and resistor R is 100 ohms, the current I is 1 amp. If you wish to control the current to 0.5 amps, then R should be 200 ohms. Controlling the current is one of the functions of the resistor. We can also deduce that voltage of 100 volts is generated between the resistor terminals when a current of 1 amp is passed through a resistor of 100 ohms. For example, resistance of 100 ohms will be used to convert current of 0.1 amps into 100 volts. Heat is generated when current flows through the resistor. This means that the resistor consumes electric power. The formula P equals E times I is derived when the voltage of the resistance is considered as E, current as I, and electric power as P. If Ohm's law is substituted here, we obtain the formula P equals I squared times R, or P equals E squared over R. Thus, as electric current increases, power consumption increases. As a result, the resistor's temperature rises due to heat generation. This means that the resistor will burn if the current is too strong. As such, each resistor has a value for maximum allowable electric power. When resistors with high power consumption are called for, products that can control heat generation by means of forced air cooling or water cooling may be used.